Hello everybody, I am going to walk you through factor analysis to give you a picture of what it all looks like in video. So this is the same as what we did in the class for us. Okay, so what this is following is the in-class lab 7, and this is updated 2020 would be the Word document. And if you look, you'll see the data set for in-class lab 7, and that data set says updated 2014, but that's the correct one. We're using the same data for a number of years. This you'll also find is the same exact data at the end of the chapter in your Mertler and Veneta textbook. So we're following their example as our information. So what you see in front of you is pretty simple to understand. We have an ID number for everybody, and then we have 8 variables, and they're all pretty obvious and clear what they all mean. We're going to follow the factor analysis checklist, which you find in the Mertler and Veneta book in figure 9.25, but there's a couple of things added to it that we generally do in psychology research. So, okay. So first we're going to just look over our data, get to know it a little bit, and see if we have any missing data. So to do that, we're going to go to Analyze, Descriptive Statistics, and Frequencies, right? And we're going to send over everything but the ID number, although, I guess you could look and see if you have any missing ID numbers, but I know we don't. So we're going to just run that, and you can see right there at the top that missing is 0 all the way around. We have 549 participants in this study, so we've got a really nice collection. So nothing missing. Very good. All right. The next thing we're going to check is multivariate outliers, and we're going to use Mahalanobis distance for that. So you're going to go under Analyze and Regression and Linear. Within there, if you remember from Mahalanobis distance, you send over the ID number as the dependent variable, and you send over everything else as your independent. And don't forget to hit save over here and the little Mahalanobis distance clicker. And, oh, that's fun. I can't reach the bottom. Okay. Figured out the problem. So we last left our story at Mahalanobis distance right there, and you click on continue, and you have clicked everything, so you can click on OK now. And you don't need any of the regression output, of course. What we need back over here is just this Ma1 kind of thing. I'm on a Mac right now, so I actually have to go in and sort the cases the hard way under data, sort cases, send Mahalanobis distance over, and tell it I want it in descending order so you guys can easily see it. And it did that. So go back and look here. If you're in a different kind of computer, you can probably just right click on that and tell it to sort descending. So for this, we now want to figure out what our cutoff is, right? So what you would do is go into the back of your textbook, into Appendix B in the chi-square distribution, and find out what the cutoff score is. We have 8 variables that we're using here, right? So everything but the ID number is 8 variables. So you would look at the cutoff score for 8 variables, and that is 26.125. Okay, so you go to 26.125 as our cutoff. So as you can see, that's going to actually be 15 cases for us. So you want to highlight those, and you can either hit your delete button, or on a Mac I have to hit clear to get rid of those. You could get rid of the Mahalanobis distance numbers, or I just chose to leave them this time. It doesn't really matter. As long as that data is all gone, you won't be able to analyze it anymore. If for some reason you're concerned about this and it didn't work well, I also left another data set in Blackboard for you that has these missing values removed, but it's not too bad, right? You guys are getting pretty good at this stuff. Okay. Step 3, we're going to look at linearity and normality of our variables. For that, we're going to look at a graph. So here we're looking for our smiles and our rainbows. So graph, legacy dialog, scatter dot, and we want the matrix scatter. And to define it, we're going to send everything over except we don't need ID number and we don't need Mahalanobis distance, right? And click OK. And you should get a graph that looks a little funky like that, right? And for the most part, it doesn't look like rainbows or smiles. It either looks like kind of like wiggly lines or straight lines or just big bad blobs. But nothing that looks too much like a rainbow. Maybe right there with that one, but that's okay. I don't think it's really a rainbow. The other thing we can do to check linearity is we can also look at the bivariate correlations between all of these and make sure they're not too high or too low, essentially. So in that case, we're going to go up here to analyze, correlate, and bivariate. This is just a way to get to know your data a little bit too. It's kind of like dating your data. And it's just correlation, so we don't need to do anything special. So here's our correlation table of our 8 variables with themselves. One of the things that's really gonna kind of make you look at it closely with this one is that we have several correlations that are extremely high, 0.96, 0.91. There's a couple down here that are 0.99 and 0.98, another one 0.99. It means basically that like life excitement and general happiness, people are answering almost the exact same answer every single time. There's almost no variability in it, despite having like over 500 people. So it makes me wonder about this data set, to be honest with you. I'm thinking it's made up data, but really who knows. I found it, from the manufacturer of our book. So, but that would make me question if I had things over 0.95 or even 0.90. And then anything below 0.10 makes me wonder whether my data is actually going to cluster onto islands at all. So we've got a few there, like general happiness and total income is a 0.05 correlation. So that's extremely low. I'm like, are we going to be able to even find anything that is an island with this data? But for the sake of learning, we're going to keep going. Another one that you can check is to look at normality. Now, you wouldn't transform anything in a data like ours, right? Like we're not going to do any transformations if skewness is bad. But we do want to at least know if we have skewness problems. For instance, if we have really high skewness on a question, then we might have where like basically everyone is giving the exact same answer to the question. You might want to go in and actually look at that a little more. In this case, we don't have anything between -1 and 1. In fact, our skewness is all sitting right around 0. Other than income and degree, which kind of makes sense, job satisfaction, even, those are still really great. So normality of our individual questions is looking really good. Okay, we're going to go ahead and now run our factor analysis. So analyze and dimension reduction factor, right? So that's where we go. We're going to send all of our variables over here. And when you do a factor analysis, you basically click on everything. So under descriptives, we are going to be adding a couple of things. We want to make sure we get the reproduce checked off and the KMO Bartlett's test of sphericity for sampling adequacy, it's called. So we're going to click on that. Under extraction, you're going to click on Scree Plot. Now, I'm not going to go back through and rerun this with other amounts of islands or factors, but right here, the default you'll see says based on eigenvalue greater than 1, which is Kaisers Rule. So the first time we're running this, we're basically saying, sure, follow Kaisers Rule. And that's usually what you do the first time you run it on Kaisers Rule. But if for some reason you decided, you know what, Kaisers Rule ended up not being a very good rule to follow, and your textbook talks about this and the 4 different kind of criteria, and you try to use them all to determine how many factors you have. If you decided, you know what, I don't want to use Kaisers Rule, I want to force it to be like 3 factors, then you would do that. Fixed number factors to extract is 3 and continue. But again, this is first run, so we're only going to do that. But I want to show you that's how you would do that. Then under rotation, you pretty much always do a Varimax rotation, and we're going to ask it to give us that. Under scores, you can save them as variables. That's kind of common, although we're actually not even going to mess around with that. And then it will make your life so much easier later if you sort by size right here. Okay, so that's all the things. We're following along with what the textbook tells us to do. We have officially run our factor analysis. All right, so let's look at our output. So this is the first thing. This is our final assumption. Your Mertler and Vanetta textbook does not cover this, but other textbooks do. So it's pretty easy to include. So I wanted to include it. And what you have here is that your KMO, test of sampling adequacy, it should be at least a 0.50, and we have a 0.80, so that's great. And then we have significance for our Bartlett's test of sphericity, so that also indicates that basically we have a good sample, that our sampling is large enough and diverse enough to be able to run a factor analysis. So that's kind of the final assumption. So we're going to now look at our actual data. This is our main data here under total variance explained. And what you can see is that first column that says total, that's your actual eigenvalue total. So remember, eigenvalue is kind of a percentage of variability that's happening, and it gives it kind of a standard number. And the number 1 is our Kaisers Rule. So this is telling us we have 2 components, 2 islands, right, or 2 factors. Those are all kind of the same thing. If we use Kaisers Rule, right? So that's a really important step for us to figure out. You can also look at the cumulative percentage of variance that's explained with 2 factors, and it's saying, you know, with just 2 factors, we can explain 91% of the variance. That's great. That's a really high number. So we're really happy with that. The other thing to check is Kaisers Rule is generally a good rule if your communalities are above 0.30 and you have at less than 30 variables. So if we only have 8 variables, so we're really good there. And then all our communalities, the lowest one is 0.75, so that's higher than 0.70. So that would all point to Kaisers Rule would be a good choice according to this. Okay, another criteria to look at is percentage of variance. I already talked about that. A third criteria is the Scree Plot. And the Scree Plot appears to show kind of 2 or 3, the elbow of the Scree Plot, which is just a visual of the eigenvalue. As you can see here, this first one is 4 point something, like 4.475, and the next one is 2.841, right? It's just a visual of it. And you can see the point at which it kind of drops off. So it's helpful to get a look at your data here and kind of see, well, maybe 2, maybe 3, not quite sure. A fourth thing to look at is the reproduced correlations. And this is actually a pretty complicated topic that we're not going to go into. We're just going to utilize it essentially. And actually the easiest thing about this one that's so nice is all you really have to do is read the footnote at the bottom here that says under B, residuals are computed between observed and reproduced correlations, and there are 4 or 14% non-redundant residuals with absolute values greater than 0.05. So that's really good. We have a nice 14%. That's a low percentage. So all of that seems to show that when we forced it to do Kaisers Rule with 2 factors, it all came together quite well. So probably 2 components. Scree Plot said maybe 3. The residuals were pretty good. So most everything is saying 2, 3 is possible. So let's assume we stayed with 3. Then we need to decide which questions go with which islands. All right. So which questions go on to which component or which factor. And for that, we have job satisfaction, hours worked, degree, years of education, and total income all have very high component scores with factor 1, right? And for this, you generally want a rule to follow before you go into the data. And a really common rule that people use is that the item has to load at least 0.50 onto one of the factors, and then there has to at least be a 0.20 difference, meaning you don't want it to kind of evenly load onto 2 factors, right? You don't want it to sit in the middle of the ocean between 2 islands and not really, kind of align with one of them. You want it to align with one island, not the other, and tell it to swim for that island, right? So we're going to put job satisfaction on island 1, hours worked, degree, years of education, and income all on island 1, and then general happiness, depression, and life excitement, those very nicely are on island 2. But again, remember, if these loadings had been a little different and we could have even had good loadings like 0.57 or something on one of the islands, but the other island wasn't a difference. Like if you subtract the numbers, it wasn't at least 0.20 of what the other number is on it, then you're going to need to drop that item and throw it out. So actually, one of the things you generally do in item development is you get rid of a bunch of items at this point in the process. And this particular data set with only 8 questions didn't get rid of anything, but just to be aware for future. Okay, and then you just want to name it. So I would say I would call the first component probably something like career, and the second component looks like something like either mood or life enjoyment or something like that. So there's nothing particularly perfect about all of that, just that you want to make sure you can do that. Now your written instructions go through how to do it again if you had to do 3 components, and so I'll leave you to look at that since you've already seen how to do that. But let's run a Cronbach's alpha for this, which tells us what the reliability is. And for that, we go on down here to scale, reliability analysis, and we can send them all over. But remember, we actually don't think all these items go together, right? They probably aren't going to be reliable because we know there are at least 2 islands, right? And you can see that. Oh, look at that, Cronbach's alpha 0.002. That's about as terrible as you can possibly be. So let's just run it by our islands, right? So what I'm going to do, I'm going to send back over these 3, general happiness, life excitement, those, and keep just the 5 on the career island, and click OK. We also get a really terrible reliability for this one, which leads you to believe something's wrong with this data. And then let's run a reliability analysis now on the other items, on happiness, life excitement, and depression, and click OK. And we don't get that grade either, 0.438. So what this is saying is that we can get principal components analysis, and we can get it to form islands, and we can assign questions to particular items and stuff, but we still have people answering questions in a really unreliable way. They're not very consistent. I think the reason is that this isn't actually a scale, right? So these are actually like separate sociological questions, and they don't really go together like a normal psychological scale would. But I wanted you to see how to do it. Okay, that's it. You have learned how to do factor analysis. Very good.